these type of facade screens through Dynamo in Revit. So as you can see, these are some voids in the screen which have kind of profiles, like it is having the hexagonal profiles voids. Okay, those profiles are decreasing at some point. Similarly, if I see this screen, this is also has some shapes like this. Okay, so the screen is basically having some voids which is changing the shape at certain points. So how can we make this kind of a screen in Revit through Dynamo? So first of all, we need to open a generic model family template. Okay, and we need to open the Dynamo in the same template. We'll see how we can export it in the project later on. So the first thing which we actually need to make this kind of a shape is the points, point by coordinate. So we need to have multiple points. Okay, in multiple points, we can make sequence. In sequence, if I talk about the wall, it needs to have a sequence in X and Z coordinates. Why? Or Y in the Y and the Z coordinates. Z coordinates is very important because we need to make a wall in a vertical format. Okay, so we can simply connect this to X. Okay, and we can make the separate sequence for Z if we have different length and height of the wall. The next thing is to make the products lacing by cross product so that we can get points all over the coordinates. After that, the starting amount would be 0, obviously. The amount. Now amount would be a slider which can detect the length of the wall. Similarly, for Z coordinate, it would detect the height of the wall. So we'll simply type out slider. Okay, amount, and we can make this also as amount. For height, we can make it maximum to, let's say, 10 meters or 20 meters. And for length, we can make maximum of 50 meters like this. Now, if we increase it like this, we can get points at the background. The next thing is we want to create a cuboidal shape or a spherical shape on top of these points. So how can we make that? If we type cuboid, so we can get this node by width, length, and height, but we want the point node as well. So we type it again, cuboid. Now in this particular node, we get the input of point as well. So obviously we want to make cuboid at each point. So we'll simply connect this with point. And as you can see, it is fully filled with the cuboids. Now we need to provide a width, length, and height. Now this is very important. We want a dynamic width, length, and height of cuboids. Why? Because each cuboid should have different dimensions. So for that, we need to create a point through which all the dimensions or of the cuboid would merge at one point. So if I open an image again, as you can see, the dimensions of each and every void or whatever it is, the form is, it is merging at one point. So we need to create another point in the project. And whatever the distance of these points from this point, this is a bundle of points, but this is a single point. So whatever the distance of all these points with this point would give the length, width, and height. Now, how can we do that? Then there is one special node which is distance to distance to. So as you can see, it will give the distance from one geometry to another. So we'll connect first the points, then this point. So it will give the distance from this point to all of these points. Now, as you can see in the output, it is giving me the value 0 till 3. Okay, even 5, 6, 7, 8 as well. But I want my geometry or length, width, and height to be from minimum to 0.1, let's say, supposedly, and maximum would be 0.9 because 1 is the distance between 2 points. So we need to make this list from 0.1 to 0.9. So there is a node which is remap range. So it will detect all of these values and convert them in a range of whatever you fix the numbers. So we'll simply collect these numbers to this. Now we'll simply type number for these things. For minimum, we'll write, let's say 0.1, and maximum we'll write 0.9. Okay. So it will give us a same values within the range of 0.1 till 0.9. Okay. And we connect this data with the length, width, and height. Now, as you can see in the background, we have the cuboids with different dimensions. Okay. Now, if we need to increase the points, we can increase it. Let's say if I increase the height, the cuboids will also increase like this. And the next thing is, by default, this point is falling at 0, 0. I want to move this point. So we can use the slider again to, let's say, X and Z coordinates. Now if I move this up, so as you can see in the background, the mm, uh, cuboid dimensions are changing. The cuboid dimension should be maximum of whatever the height is. So for height, we have kept it 10. So now this I will kept it as 10 only. Now if I move it, you can see the clear difference. Okay. Once it's done, before moving forward, let's check the unit of the uh, template. So the unit of the template is mm. And as you can see, whatever the dimensions we have put, 10 is too small. So we need to make the dimensions of the template to be meters. After that, we'll check it again. We'll need to switch on the background view of Revit. Yeah, so as you can see, the profile is here like this. The last step is to make these profiles loaded in the Revit environment. So we'll use the node which is form geometry. And this is a special package you need to download. This package is a Spring package. So if I show you, this is Spring Revit.create. You can type this out here in the new package and download this Spring package. After that, we need to connect the cuboids to geometry. It will take some time and it will convert the dynamo geometry in the Revit. Okay, as you can see, whenever we select it, it is a solid geometry which has been created. The last thing is we need to create them as void. So is void is by default false. So we can use Boolean node and we check it true and connect it. So all of these forms which are now created is void. After that, we can select this option off and we'll load into the project. So for project, we'll simply open one template And after that, we'll load this thing up in the project like this. Now if we create a wall and let's go to 3D. So if we cut the geometry from the wall, it will look somewhat like this. Okay, we need to make it in the center. If we drag down like this, now in 3D, sorry, in 3D, you can see the wall which has been built like this.